All right, so we're in lesson 4-1 here. Direct variation. And so the first thing you need to know about direct variation versus inverse variation, I think the book only refers to the inverse variation part. They've already done the direct variation before, but just a quick reminder, direct variation as y changes, then x changes in the same ratio. So if x gets bigger, this k is always a constant number. So if x gets bigger, then y has to get bigger. That's what I'm saying right here. As x goes up, y goes up. But if we're going to solve this for k, just an idea that sometimes can also be helpful. If they give you a table of data and they ask, is it direct or is it inverse? Then what you're going to look at is, if I take my one variable divided by the other, do I always get a constant? Or if you do inverse variation, which is what we're talking about in this lesson, y equals whatever your constant is divided by x. So when x goes up here, you're dividing by a bigger number, that's going to cause your y to go down. And then in terms of an equation, if they give you a table, this relationship again is helpful. So if you solve for k here, multiply both sides by x. When you multiply x and y and you get a constant every time in the table, then that's going to be an inverse relationship, inverse relationship. All right, so let's try a couple of problems. So if y varies directly as x, and it's like a two-step process. So the first step is when they give you two of the numbers we can solve for k, and the second step is then they tell us one of the other numbers, and we already solved for k, so we can solve for the missing variable. So let's see how this works. Y varies directly as x. Remember how that sets up. So as x goes up, then y goes up. So if y is 10, when x is 3, so when we solve that, we're going to divide both sides by the 3, so that k is 10/3. Now the second step, so when x is 7, so go back to your original equation, so that's 7 in place of the x times the k that's right next to it, 10/3. We get the y value for that, which if you put the 7 over a 1, 7 over 1 is the same as 7. And remember, multiplying fractions, you multiply straight across. So like 70/3, or if somebody wanted to divide that out, I suppose that's like 23 1/3 in decimal, 23.3 repeating, whichever form of that they're looking for. Well, now let's look how it works inversely. So I've got the exact same problem, same numbers, but it's an inverse relationship. So for this problem, y varies inversely as x. Oops. So y varies inversely as x would look like that. And so when y is 10, x is 3, and then multiplying both sides by the 3 to solve for k. So k here is 30. If k is 30, and then the second piece of the problem, k is 30, x is 7, use those to find y. So the problem again sets up as we have right here. Y equals k, which was 30, over x, which is 7. And so you could just stop there or divide it out. 7 into 30 is 4, with what's that, 2/7 left over. And so that's how a problem compares with the two. Let's go on here. How do you graph this thing? So this y over x graph, if you think about a table. So if I have x and y, first of all, x can't be 0. That's very important here. You can't divide by 0. If we had 1/0, So if you put a 0 in here, that's a big that's something that's going to be known on the graph as an asymptote. The graph approaches it. Some people will erroneously sometimes say that the graph doesn't cross the asymptote, but that's not truly correct. In some problems it will, but it approaches it. It keeps getting closer and closer and closer. All right, so, and I'll show you, there's a sinusoidal example of that, but if x is a fraction, so let's say 1/10, so you have 1 over 1/10. If you remember back to division when you learned that, if you took this 1 and split it up into 1/10, you'd have 10 of those pieces. And so if you remember, that's how division works. You know, if you put in a half, if you take 1 and you split it into a half, in each group you'd have 2 groups, right? So that's division of fractions. You can't do the 0. Let's say you know, on the negative side, if you put in a negative 1/10, you'd get a negative 10. If you put in a negative 1/2, you have a negative 2. You know, you just positive have a negative. If you have a negative 1, you'd have a negative 1 over 1. If you put a positive 1, it'd be a 1. And so if you look at the graph of those, here's what you should see. And you know, they call it the reciprocal function here. It's really going to be the basis for what we're going to be working with in these things called the rational or the inversely related. So there's some different names you might look at here again. So when we were out here at 10, we were at 1/10, which means getting close. When we were over here at like 1/10, we were clear up here, and when we were at 1 and anything in between. And so this is going to be this kind of curve. Sometimes you'll hear the word hyperbola on graphs of this shape. And then over on the negative side, you're going to have all the same thing where it's fit right in that quadrant right there. So that's the basic graph for these reciprocal, as they're going to refer to them, but they're also a foundation. Now, where this line, x cannot equal 0, that is what's called the asymptote. And if you notice here, we also have a horizontal line on the x-axis in this case where it's approaching it as well. So we also have a second asymptote. Now, the vertical line, remember on a vertical line, x cannot equal, so that would be like the equation x equals 0, which in my brain, it's backwards for me, a vertical line. Any place on this line, x is 0, so that's that vertical line. On the horizontal line, this one down here, that's the equation y equals 0, because you never go up or down, so your x is any number you want left and right, but y is always 0 on that horizontal line. So asymptotes, the basic graph of it, those are some of the key features that we have. Moving on. Well, what happens if you get a problem right here? Now, what we're trying to do is look and see. Remember what happens when we have a -3 attached to our x there? So remember, what we just found on the last example was we had our 2 graphs here and here. This is going to move the graph right 3. And then this is going to move the whole graph up 2. So what we're going to do is we're just going to move our asymptotes. So remember we had our vertical asymptote here? Well, if we go right 3, my new vertical asymptote is going to be over here at x equals 3. If we move up 2, my new horizontal asymptote is going to be up here at y equals 2, because anywhere on that line we're always up 2, well that's y, and any place on this vertical line we're always right 3, x equals 3. And then there is no stretch factor here or in front of the fraction, so then we're just going to put that new equation. So our graph of this is just in these 2 new locations. with my asymptotes being used to help find those. I don't know that I truly go right through the origin. Like if I put in an x of 0 here, that'd be a negative 1/3 plus 2. I should be up a little higher on that graph. So if I put in a 0, my y should be positive. So let's just make sure that that's fit in there just a little bit more accurately. And again, you could take a couple of key points if you would like here as well. In fact, I think it's going to be up higher than 1 even. So, or if you wanted to put in what would make the x 0, or what x would make the whole thing be 0, so we found our y-intercept there, we could also solve and figure that out as well. Well, we could do that here. Let's try that quick. So if we had 0, this is for finding my x-intercept. The y itself is 0, so I'm putting that as a 0. And I have 1 over x minus 3 plus 2. So I'd subtract this 2 to the other side. Multiply both sides by the x minus 3 to get it out of the denominator. This is just one method. You might have another one, negative 2x plus 6 then equals 1. Right, if I multiply those, that just leaves a 1 over there. If you subtract that over, that'd be a negative 5, and divide by this negative 2. So I'd really be at a negative when that doesn't really make sense for my graph. Wait, that was a negative divided by a negative, so that's a positive 2.5. All right, so that makes better sense. So it should be going right through there for the other side. If we wanted to really make sure our graph was a little more accurate in terms of over here. So if I take this out, and if I'm supposed to be hitting right through there, you know, something more like that. But you can get your graph as accurate, but the biggest idea we're looking for is getting it kind of placed in the approximate position here based off from the asymptotes. So hopefully that helps, and that's lesson 4-1 in a nutshell.